And welcome to the Desk of Lady Ada.
Hey everybody, welcome to a midnight edition of Desk of Lady Ada. I thought I would show a project that I worked on today, and it was so much fun that I would love to share it with you. I am making a CircuitPython powered keyboard emulator, basically like a keyboard, for Mr. Lady Ada.
Yeah.
Who you don't see, but just trust me, is here doing camera control. And Mr. Lady Ada does so much video, like turning me on, and like doing the back and the front and the labels. And he asked me, hey, I want basically a control box with 6 buttons that I can press that will bring up different elements in Wirecast, like using control keys. That's correct, right? That's correctly.
Yeah, and I got a device, and it doesn't really work.
Yeah, you got a device from like 1996. But what?
I mean, it's recent.
Yeah.
Right.
Is it? I thought those were made like a long time ago. This thing.
Yeah.
This like turning knob.
You can put it on the overhead.
Yeah, we'll turn on the overhead.
And then plug it in to show it's a...
Well, I don't want to plug it in because I don't want, it'll probably need to install sorts of crazy drivers. But it basically also acts like a keyboard. It's called the PowerMate USB. And it's a button and a knob. And this is kind of close to, you want something with more buttons. But this is kind of nice.
Yeah, so the way this works is you can do a press and hold, you can turn it. And I had all the Wirecast stuff mapped to it, and it would work for a little while, and then it wouldn't, and it would
crash.
Glitch the keyboard.
Yeah, that sucks. So I was like, well, this is like super easy for us to make. We could make it with a trinket. But I thought, well, let's maybe use the new Feather Express, which can run CircuitPython. And I wanted to see, because I wanted to also, I wanted to build something for you, but one of the problems with building like a Trinket or Arduino thing is that I give it to you, and then if you want to upload the code or change the key commands or whatever, you have to like recompile it. Whereas with Python, the code lives on the device, and so you can update it very easily.
And I have, I'm moving towards our Arduino IDE free computers, where it's not installed. So I'm just doing a lot of testing with web stuff, and so I don't want an IDE, so I just want to be able to plug it in as a USB drive, edit a text file, and it just auto saves, and then it's just done.
Yeah. So let's check this out. So let's go to the computer. So I'm going to be using the Feather M0 Express designed for CircuitPython. So this is an ATSMD processor. It has a NeoPixel and some SPI flashers where the code is stored. So the code doesn't get compiled and then uploaded. It actually lives on the board itself. So this is my CircuitPython device. It's called CircuitPy if you go to the computer. It's a 2 megabyte drive, and inside of it, it contains the code. And the part that actually acts like a keyboard is Adafruit _HID, which is a library that adds keyboard, key code, and mouse commands. So you can also have it act like a mouse, but I'm going to be using it as a keyboard. And let me delete main.py because I'll make a new one so we can start from scratch. So you can call it main.text, but I like to call it main.py. And do you want to maybe like zoom in on this area? And I'll also open up a serial port. So you can connect to the REPL pretty easily.
Where do you want me to zoom into?
Hold on. Just 1 second. I have to figure out what the device is, and then once I bring it up, you can reset. COM port is COM57. Okay, let me try this again. Serial. Okay. So let's have it be just from that section on. Next section here. Oh, and including the text above, because I have to edit. I'm going to write the code up here. So, yeah.
Like this?
Yes, exactly. Thank you. So, when you write Python, your code goes into main.py, and I'll just copy over the code that I do have, and I'll just do it line by line so I can explain it line by line. So, first up, I'm going to import Digital I/O. That's the library that lets you do GPIO input-output. From board import star, that imports all of the pin definitions. import time lets me delay, time.sleep. And then from Adafruit HID keyboard and key code, I import keyboard and key code. So that's the commands that let me create the keyboard demo. And then a little description of what I'm writing here. And then if I save it, it'll automatically reboot, but there's actually no output. Like I don't have any code quite yet. So let's start with button equals D12. And actually, let's create a device, an object. So to create a pin, I call digital digital input out. It creates a new pin. And then I have to tell it that I want to turn it into an input. So I type in switch to input, and then I'm going to tell it I want to pull up. And I'm also going to create an LED and switch to output. The LED will be used for debugging. So I'll save it. Still nothing's happening with the REPL. Okay, so now I'm going to add a little print just to let me know, okay, my code is running. And now when we save, and again, every time I save, the REPL restarts. So you can see down here, it says waiting for button press. Here, I'll make this even smaller. Waiting for button presses. So I'm ready to actually start writing code. So what I want to do is I want to have a loop, right? Because I have like a while loop, and then while the button isn't pressed, while it's not pressed, I delay, and when it is pressed, I want to print out something. So let's start a loop. While true, typing. And then if not button value, print pressed. And then else, print not pressed. So this is just a simple loop that just will let me test the button. So right now it just keeps saying not pressed, and then if I press the button, it says pressed, not pressed, pressed. Super easy, so fast to development. Okay, so next up, I want to, when the button is pressed, I want to then wait until it's released. So while not...
You need to bounce. So also.
You don't really need to debounce because Python is a little slow. So like these commands, it's like a millisecond between, we can add a debounce, but it turned out that because I ended up sending a key command, the bouncing wasn't required because it's like there was a delay with the bounce. So I'll add a while not button value. So that's basically saying like while it's not pressed, just hang out. Okay, so now it's been released, and now I'm ready to actually do something. So I'm going to get rid of this because I don't need this anymore. And then what I'm going to do is I'm going to set the LED true and false. So the LED will light up until it's released. So let's go to the overhead real fast, and I will show this running. Okay, so when I press it, you can see this little LED light up, turn off, light up, turn off. That's it. So now I know that my button presses are being detected. And if you go back to the computer, you can see every time I press the button, it says pressed. Great. So I'm actually almost done. All I have to do now is send the keyboard command. So over here, CircuitPython.readthedocs.io, there is information about HID keyboard and how to use it. And here's an example. So you can press Control-X by basically sending keyboard.press and then send the key codes. And then when you're done, you just have to release. Otherwise, it holds it down, right? Which is, trust me, I went through that, and that was not what I wanted. So we will make it so when you press the button, it will keyboard press, and then I want to maybe type in the key code A. Just like, the letter A. Key code A.
And where would you get a list of all of the key codes for like a Mac? Because I need to do Command Option 3.
Good point. What you would do is under key code, this list, there is a list of all the key codes. Well, one thing we could do is we could, remember we had to do this with the next keyboard.
Yeah, we have a next keyboard.
You basically look it up here, and what I would probably suggest for you, it's actually easier, is you would download a little like app that tells you what key codes you've pressed. Like, it's really common, because we had to do this with the next keyboard. Was like, what keys are you actually pressing to generate
and I'm pressing 3 at the same time.
That's fine.
Yeah.
We can handle that.
So
let's just start with this keyboard A.
Quick question about CircuitPython, MicroPython. Can it be compiled down to bytecode on execution?
No, it's not. Well, it is compressed when it is run, but it's stored as text. And that's on purpose. We don't want to compile it down to just raw bytecode on the disk. We do it in memory to execute fast. But just like Python, you edit the Py script and it runs whatever is in the text. The whole beauty of this is you don't have code on a microcontroller that you can never edit again. Like, your code is always there. Like, when I write the code, it runs, and then after I give this to Phil, if he wants to change the key codes or key commands, he'll just go in, type something, and save it. There's no compiler. You don't have to install a library and have the right Arduino IDE and board support package. It's all contained.
I'll tell you a cool thing too. When I'm doing all these shows, sometimes we have guests. Sometimes I change my key commands based on the show. So my show computer doesn't have really anything other than just all the tools I use to broadcast. So being able to pop it in as a USB drive, double click it, edit text file, and it just works is pretty cool.
Yeah, and you can have, you can have multiple different code that, you can have one called show.py or deskoflady.py, and then each one of those has a different set.
Yeah.
We can also set a switch. You can change the modes.
And
or
I just rename it
clone it
to main, and then when it auto restarts, that's the one it runs.
Yep. Okay, so now I've just added two lines of code, keyboard press and keyboard release all. So let's try it. I'll put my cursor here. Press. Oh, it says keyboard. Oh, good. I have an error. So it says traceback main.py line 23, and that's this. It says keyboard not defined. Oh, I forgot. I have to create the keyboard object. So let's do that up here after the button and LED. So I have to create the keyboard object, which is you just create the keyboard object, save it, and let's try again. Okay, press. This time there was no failure. But let's put my cursor here, press it, and you see little A's appearing. Yay! So this is why, just don't forget the release all. The first time I wrote this, I was like, oh, press will just send one key code, and it started sending A's, and then I had to unplug it. So that was kind of fun. But then you're like, well, what if I want to send multiple key codes, right? You said not just A, but shift or something?
Yeah, it's option command 3 is one that we could do, but a person in the chat said for that you would use Windows key and Alt key. That's the key command?
Yeah, probably. That said, there are, so there's all these function keys, print screen, delete, left arrow, up arrow. Let's see if there's there's function. Let's see if there's shift. So left shift, or just shift. So let's try shift. Key code, shift, key code A. So save this. And now let's try pressing the button again. This time you see we have capital A's, because it's pressing shift and key code A at the same time. So all we have to do is basically update, we're going to figure out what key codes exactly you need. I don't want to do it live because I don't want to send a key code that turns it control delete, you know what I mean? But you can basically customize it. And then what I actually did for the final code, so that's a simple code, and I'll actually, I'll save this as a simple key.py. And then I'll go through the code that I actually ended up writing because it's a little bit more complicated. And it kind of shows the beauty of using Python. So what I did is I created button pins. So this is an array of the 6 pins I'm going to use, D12, D11, D10, D9, D65. And if you look at the feather, that's these. Hold on, let me get really close. Nope, that's not how you do it. Sorry, one moment. Open, link in new tab. There you go. So you can see you've got pin 5, 6, 9, 10, 11, 12. So I picked these 6 pins because they're easy to get to. And this is an array. And then I have the matching key code. For now, I just picked A, B, C, D, E, F, very easy. And then the control key. So this is the key, because I wasn't sure exactly what Phil wanted. So I just said, okay, well, I'll have one control key, but I can have multiple control keys. And then for each pin in the button pins, I turn it into an input. And I set it to be a pull-up, so that goes through D12, 11, 10, 9, 6, 5, and does that. And then I append it to an array of button objects so that later on I can query which one was pressed. I still have the LED. And then instead of just a simple loop, I have a double loop. I do have a while true, so like constantly checking, but for each button in my array, check if that button is pressed. If it is, get the index of it, like which input it is, and then get the key, the corresponding key code, print out which button number was pressed, turn on the LED, and then press the control key plus K, the indexed key. So basically, when you press D12, it'll do key code A, D11, key code B, D10, C, D9, D, etc. So Phil can then edit this, and it'll just, whatever lines up with these pins will be the key codes that are pressed. So really easy for him to update it. So it can be function keys or letters or numbers. And then it just iterates over all of the buttons. So let's change this to be shift, so it's a little easier to read because the controls are hard to see.
Oh, a couple shout outs. Shout out to John Anderson who gave us $5.
Nice,
super
thank
chat.
you.
And then shout out to Dan Halbert. Thanks for using my library.
Thanks, Dan Halbert, for writing this awesome library with Scott. I
Yeah.
did notice, I should have shouted that out. It's in the Read the Docs. This is a project by Dan Halbert and Scott
Just think,
Shawcroft.
Dan, every time we use a camera live, it's going to be powered by the library you made.
And here's another thing that's interesting about this library. So Phil, can buy go to the Apple Store and buy any, whatever dongle. But, when we're working with people who are doing accessibility projects, or, we had somebody on our show recently who they made a electronic page turner, foot pedal page turner for their grandmother. And so when she pressed the foot pedal, it would send basically a key command to turn the page on her tablet. And wouldn't it be cool if instead of being like, hey, download Arduino, it's like, okay, here's some code. All you have to do is just change the key commands and you're set. I think that would be so cool to do. I think this is very empowering and so simple because every computer has a text file editor. And the fact that I can save this as main.txt and then anybody can open it and edit it, it's just it's a beautiful thing. So, so we saved this, and now, so again, we have multiple buttons. So let's go to the overhead real fast. I'll just show that I didn't have time to hook up 6 buttons, but I hooked up 3 buttons, and each one goes to D12, D11, D10, and then there's a ground wire. There's a pull-up, so I don't need a pull-up resistor. That's built in, but I just do have the other side of the button connected to ground. And then back at the computer, I will press these buttons, and A, B, C. Super easy. A, B, and C, and it's printing out which button is pressed, so that's good for debugging. And this is super easy. So that was, only 20 minutes from beginning to end to show off making a custom keyboard controller and going through the code line by line. What's neat is earlier when I was doing this, once I found the Read the Docs, it was only 5 minutes. It was the fastest project I've built. So awesome. That's it. That's the project. So easy. So we'll put this up in a Learn guide. Maybe I'll make a quick one-pager. Then Pedro will help us design a really cool box with arcade buttons. I want to use our new mini
What IDE
arcades.
are you using?
What IDE?
Yeah, which is basically a text
This
editor.
is not an IDE. This is Emacs. It's just a text editor.
But that's what's cool is you don't need anything.
Yeah, I purposefully am
You
not
can use a Chromebook.
using anything more complicated than Emacs. Eventually, I'll use Moo. I'll get
Yeah.
around to setting that up.
You can use.
But you can use simple text.
Any phone could be a text editor.
Actually, let's maybe show how you can change. Okay, so this is my backup code. If you go to CircuitPython.
Yeah, you could just duplicate that and then call it something else.
Yeah, but check this out. I can call it main.text, and then I can edit it. Oh,
Yeah.
no. Hold on. I have it set up so it automatically opens in Emacs, but, oh man, not Notepad. I meant WordPad. One moment. So, it's ridiculous, but you can write your code in WordPad. You know, like, it's a little silly, but you can do it.
Yeah, and the other thing is, I have
Maybe
to
I'll
look
make that
the list, but there's a list of files that it looks for. And I don't think you need to even call it main.py.
No, this is main.text.
Yeah.
So what's neat is by calling it main.text, it automatically opens in whatever text editor that you have on your computer, whether it's a Mac or Windows or Linux, or like Simple Text or WordPad.
Yeah, I think like code runs automatically, like to make it easy for kids. I have to look at the list, but
Yeah, there's a couple of new updates, but this is it. This is the code, and yeah, it's super simple. And so we're gonna find out what key codes you want,
yeah.
and then we're just gonna update the code a little bit if necessary, and then that's it. You get to use it, and you'll update it, and then if it works out for you, we'll make multiple ones, like one for Desk of Lady Ada, one for Ask
Yeah.
Engineer.
What's really cool is, excuse me, I can put this on my setup with wires and put the button actually on anything. So when you walk over to something, you can just press it, and the camera will switch to that.
Yeah.
That's cool. That's really cool.
Yeah, but you still have the setup that you're used to and you like. You don't need like some weird hardware box. You're like,
No,
this
but
is
I can run a key press, like it could be anything that says it's been pressed.
Yeah,
And when you walk over to something, you wave your hand and it could switch over to that camera feed.
totally.
Yeah.
All right, that's the project I did.
Okay. Oh, PyCharm EDU is what some folks suggest. They have a free edition and it's used in schools, and Shane is a tech coordinator. So I'm going to check that out. Thank you.
Yeah, I'll check that out. That
Thank you,
sounds
Shane.
cool.
That is neat, especially if schools are using it. Hey, Shane DeRuyter, email pt@adafruit.com. I'll send you out a CircuitPython. Because if you're using Python, you'll really like CircuitPython Express, because you can just use anything you're already using.
Yeah.
Your suggestion got you a free Circuit Playground board. So email pt@adafruit.com, Shane. Okay,
Yes.
one question. How does CircuitPython handle interrupts?
It doesn't, I don't believe we have interrupt management right now in CircuitPython, but there's also been a bunch of revisions. There's usually callbacks, or like, basically, functions, because like functions are objects, but I don't think we have the same kind of interrupt management. That said, CircuitPython's not nearly as fast, so things that would normally use interrupts are often just built in with C and then have like a Python hook. So like a lot of this, the HID code, for example, is written in C. It's not written in Python because you need to have underlying register support. So instead, that stuff is written in C and put into the Python core.
Okay. Are exec keywords supported in MicroPython?
Or what?
EXEC keyword supported?
I don't know. That's a good question. I don't know what's built in. I've only been playing with like GPIO and like this stuff. I know we support most of Python, but like some things like throwing exceptions is not. It's
Yeah, the
not
goal is for it
100%.
to be as Pythonic as possible.
It's as Pythonic as possible in like a $2 microcontroller.
Yeah. It's a little pocket universe. Okay, everyone. That's Desk of Lady Ada.
Yeah.
We'll be doing show and tell and ask an engineer tomorrow. Thank you.
Thanks, everybody.
Say goodbye.
Bye bye.
I'm going to try my new keyboard.
Yes.